Okay, guys, I want to show you something today. I want to show you a simulation where I'll show you that almost always a gambler is likely to lose no matter how much money he comes up with. Okay, so here's a program. This program tries to simulate how or why a gambler always loses. So what happens is that it's not really that complex. We do a loop over here with initial amount going from first of all 1 and 2 and 3 and 4 up to $30, and then we play the game, and we will try to see how much turns does it take for the gambler to go to amount 0. Now what happens in this program is first of all I'm initializing number of plays to be 0, so that we can later on check how many plays has it been for the gambler to lose. And then let our cash a gambler has be the initial amount, yeah. And then while cash is greater than 0, until he has some cash, what we will do is this x be a random choice between heads and tail. Yeah, and this be the real heads or tail that is thrown in the dice. I mean that is thrown in the dice, and this be the heads or tail that the gambler chooses, right? And if those are same, then yeah, we will print a yeah, and the cash will increase by 1, and then the available money will also be the cash which is increased by 1. Yeah, he will have one more cash than he had brought with him. If they are not same, then of course he will lose. The cash will decrease by 1 and available money will also be printed. And each time he plays, the number of plays will increase by 1. We are going to end at the end of if while the cash becomes 0 and we get out of this while loop, we will print that how many turns does it take for him to ruin himself with the initial amount that he brought with him. And this will print it 30 times because for 30 different cash amounts this loop is running, right? So yeah, let's simulate this and try to see that for up to the amount of 30, does he always lose or not? Yeah, let's see that. Okay, he took 0 turns to ruin yourself with 0 amount of money. That's true. If amount is 0, of course, he is ruined in the first step itself. Now, second, it took you 7 turns to ruin yourself with 1 amount of money. Okay, so when he comes with just $1, first of all, he gets it correct. Money is 2. No, incorrect. Money is 1. Again, correct. Money is 2. Correct. Money is 3. No, money is 2. No, money is 1. No, money is 0, and he ruined himself. So it seems that with $1, it just takes around 7 turns. It can be in 1 turn as well, because if he had got tails in the first, if he had not got the correct answer in the first step itself, he would have ruined himself. Yeah. So anyway, with the random choice as well, he ruined himself. Now, if he had brought $2, it took him 32 turns to ruin himself with $32 of money. If you want to see what happened with $2, yeah. So initially he got no, he had $1, he got S, he had $2, yeah, $3, no, $2, no, $2, and it went until in 32's turn he ruined himself with dollar. He ruined himself. Now let's start with $3. Yeah, he ruined himself at 321 turn. I was surprised that he could play for so long. Yeah. He went up to $8, $10, $13, dollar. Oh, he went up to $21. That's so high. He really had a good luck. Okay, now let's play again. Okay, now with $4, it took him 20 turns to ruin himself. See, everywhere he is going to 0. No matter how much money he is coming up with, is eventually going to 0, right? Even though we are just decreasing 1 at a time, he is always going to 0 at some point. So that means he's always going to ruin himself. Okay, with $5 at 913 tons, he is ruining himself. $6, 208 tons. $7, 23 tons. $8, 48 tons. $9, 29 tons. $10, 400 tons. $11. It seems like he has a good luck with $11 because he is still playing and playing and playing. But yeah, in no matter how much money he had, eventually he ruined himself after playing for 81,693 tons. It seems like he was lucky because he did get some good yes, but later on no, 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 and he was ruined. Okay, fine. Now $12 ruined himself. $13 ruined himself. $14 ruined himself. $15 ruined himself. $16 ruined himself. 17 ruined. 18 ruined. 19 ruined. 20 ruined. 21 ruined. 22 ruined. 23 ruined. 24 ruined. 25 ruined. 26 ruined. 27 ruined. 28 ruined. 29 ruined. 30 ruined. So, you see that whatever amount he brought with him, it really like a game with a really large number of tons. If you play for infinitely, eventually you are going to be ruined. So you see that never ever gamble. Now, if we want to discuss on this, why does the gamblers always lose? A simple logic might be something like this. Okay, let's say this is a number line, and there's a 0, and there's, let's say, some amount that you have brought with you. Let's say $5. Yeah. Now we know that from the law of large numbers, if you toss the coin infinitely, all the 50% of the time we will get head, and half of the time we will get tail, right? Let's say if we toss millions of times, or let's 2 millions of time, it's likely that 1 million times we will get head and 1 million times it will get tail, right? If that's a fair coin, that is what the law of large number says. Now over here also, if we start with 5, it is equally likely that, like, however steps we go to this side, we'll also be going that to the other side as well, right? It will not happen that we'll just go in this direction up here, but not just this one. I mean, it is not like, it's not really fair that for a fair coin we'll go a lot in one direction and not in the other direction, right? Because the both +1 and -1 are equally likely. So that's why if he is going, let's say, this much steps in this direction, he should also be going similar in the other direction, right? Yeah. But in the other direction, if he goes to 0, the game ends. If he goes to 0, the game will end. In this direction, it will not end, right? But over here, once he goes to 0, that ends. Yeah. So just the thought process is the likeliness of the both directions are same, right? Now, if he goes to this direction, he will again come back at some time, because it's equally likely that the other should also be there. The other, like, if heads is there, tail should also be there, because they're equally likely. Yeah, so she will be coming back. But once he goes to other direction, he won't be coming back and he loses. Yeah, so just making sense of the equally likely fact, I think you can see why he will always lose. This is just an intuition. It's not a rigorous maths proof. Just an intuition from me. So anyway, I hope you enjoyed the simulation, and you got to know the fact that you are always going to lose. So just do not ever gamble. Gambling is really dangerous, guys. If you gamble, you will be like him, very poor. Okay, thanks, guys. If you have any other views on this, please drop in the comments. I would love to read them. Thank you.